Welcome students, welcome to BVR Physics and Chemistry Made Easy. Today our topic is structure of atom. In this structure of atom, we are going to study about 3 rules to be followed while filling electrons, that is in electronic configuration. The 3 rules are what? The first one is Aufbau Principle, second one is Hund rule, and the third one is Pauli's exclusive principle. So the first one, Aufbau Principle. What does this principle state? The incoming electron occupies the orbital which has least energy. So the incoming electron will occupy the orbital which is having least energy. That is what it states. Now, before explaining this one, I'll give you some examples. So water is flowing like this, okay? And it has to go away like this. So imagine it has to go away like this. But in between, there is a pit over here like this. A pit is there. So water flow is like this. Now you tell me, will the water go away like this without filling this pit? No, not possible, isn't it? First, what happens? Water, actually it is supposed to go away like this, but still what happens? When the water flows, first it will occupy this part, and this is what? It is least one. It is lower one, lower. Same. So it is same. So you can imagine this as incoming electron. So the incoming electron, instead of going to the higher area, which is higher than this pit, it first occupies this pit. That's what it is. So electrons, the incoming electron occupy the orbital which has least energy. This is one of the example. The other example is what? We can take number of examples. The other example, let us take a classroom activity. This is the classroom. And you have a blackboard over here with the teacher's platform. And there's a door over here. Imagine there's a door over here. And these are benches. And there are students. This, you can imagine this class after the vacation. Okay, after the vacation. So these students are already sitting in the class. Then comes a student saying that, excuse me, sir. So teacher allowed that student. Let us consider that student as electron. And what electron he is now for us? He is the incoming electron. Actually, his place is here. Okay. Actually, his place is last bench, middle one. Now, teacher said, yeah, come in. So imagine, there is as such not necessary to imagine. It's understood for us that this student is supposed to go and sit here. Supposed to. There's nothing in this plane activity taking place here because he is supposed to sit here. He is given this place, so he is following the same thing. But what happens? Teacher immediately says that, why are you going to your bench which is in the last? Not necessary, isn't it? There are very few students today. Why don't you occupy this place? Why don't you occupy this place? So tell me, what is the activity going on here? What is the teacher is telling? It is Aufbau Principle only. He is saying that suppose this fellow is an electron, so he is not supposed to. Teacher is saying not to sit at his place, which is in the last bench. Instead of that, teacher is asking him to sit in the second bench or benches which are very close to the board. Now, what shall we treat this board as? Board is nucleus. What are these now? This is K shell. This is L shell. K shell. L shell. K shell is equal to N is equal to 1. 1 means you will find 1 as 1, 1 as 2's. And when you speak about L shell, N is equal to 2. You will find here 2 as 2 and 2p6. Like that. The incoming electron has to occupy orbitals which are having least energy. That's what it means. Here the least energy is what? People sitting very close to board. What is our board now? Nucleus. This is another example to explain the same rule. So the incoming electron occupies the orbital which are having least energy. Now, according to our science concept, let us take the example of potassium. Right? Potassium symbol is K. The atomic number of potassium is 19. Electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. To explain this Aufbau principle, remember we have to take the next energy level, and that will be 3d with 1. Now we have to decide to whom this electron should be given. So there is a competition between 4s and 3d. Now how to decide? It is we have to calculate n plus L value for these two, 4s and 3d. Now 4s and 3d. So you know n value, n is equal to 1, 2, 3, 4. These are all n values. L value start with 0. So it's 0, 1, 2 and so on. So 0 is considered as S, 1 is considered as P and 2 is considered as D. So what happened here? 4S. So it is 4 plus S. S means how much? 0. 4 plus 0 is equal to 4. Now what is n plus L value for 3D? 3 is n value 3. D means it is 2. D means it is 2. Therefore the answer is 5. Now tell me what happened. Who should get this electron? 4s1. Why? The n plus L value of 4s is less. Understood? Very good. Then you will have a doubt, isn't it? Anyone in the class can ask a doubt. What happens if both become equal? That is why the right example to explain Aufbau principle is scandium. Scandium explains the total law. Total principle it explains. Okay? We'll see that one now. Let us take scandium, whose atomic number is 21. And the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. With this we have finished 20. So it is like this, you can count on. 2 plus 2 is 4 plus 6 is 10, 12, 18 and 20. Since we are writing it for 21, then it is 3d1. As I told you, only for the sake of explaining Aufbau principle, you have to go to the next energy level, and that will be 4p1 according to your molar chart. So n plus L value, n plus L. What is n? Principal quantum number. What is L? Azimuthal quantum number. So we are calculating principal quantum number and azimuthal quantum number for this 3d and 4p. 3d over here and 4p. Now what does this 3 indicate? 3, 4, n values. How? N is equal to 1, 2, 3 and so on. So 3, nothing but it is n value. 4, it is also n value. Next plus. Now what does it mean? N is equal to 0, 1, 2 and so on. These are S, P and D. So since it is D over here, D means it is 2. Value of D is 2. Therefore 2 and the answer is 5. Same way it is P now. P means the L value of P is what? 1. Therefore the answer is 5. You remember just now I explained you potassium, where there is a variation in n plus L value. Right? So that model does not explain the total thing. Now what happened? Now n plus L value is same. So you should know what should we do when n plus L value is same. Therefore scandium is the best example to explain Aufbau principle. Now let me tell you, if n plus L value for both the orbital is same, then the incoming electron should be given to the orbital whose n value is less. So which one is having lesser n value? 3D. 3 is the least n value, 3D. Therefore, scandium atomic number is 21. So you need not write 1s2, 2s2, 2p6, 3s2, 3p6. Up to here you can just consider it as argon, because argon is an inert gas. And the remaining is what? 4s2, 3d1. No more 4p1 now, because the least n value for 3D, since both these are same, we have to go for this type of thing. What is that? If both have same n plus L value, then the electron should be, the incoming electron should be given to the orbit whose n value is less. The n value of this d orbital is what? 3. Therefore, this is final one. This is how we explain Aufbau principle.